Okay, cool. So again, good evening and welcome you all to the mathematics class. So as you can see from the screen itself, like today we are going to the start again the chapter that is functions and ITF, that is part 3. So what we have done so far, is like in the summer vacations we have before that summer vacation we had covered matrix and determinant, correct, and after that post the vacations we had two classes, right, two math class. On that class we primarily covered the relation, completely on relations, right? We know what is relations and what are the type of relations, right? Reflexive, symmetric, transitive, and then the equivalence relation, one of the most important concept both for the competitive exam and in terms of board as well. So that we saw in last two classes, right? So overly we have a very good idea on the relations, type of relations and relations. Now today we are going to start functions. Primarily in today class, though the chapter name is function and ITF. As per your CBSE syllabus, the first chapter is actually function. Then the next chapter is ITF. But here in Avanti, we just combine both the chapter together, and it will consider as a single chapter. So in this entire chapter, we are going to cover the entire functions as well, right? And the ITF, the inverse trigonometric functions. I hope you might have covered, or in some schools it has been started, I guess. Okay. So this is all the functions and ITF. Okay. So part 3. So today we are going to discuss broadly on the functions wala part. Okay. Functions. So what is the importance of the functions? I will let you know in next 2-3 minutes that what is the importance of function in class 12. See, if you see the entire syllabus of class 12, right? Post the functions, the immediate chapter is actually combining this is comes under functions only. So let's say the next function is ITF. Sorry, next chapter is ITF. Got it? Right? Inverse trigonometry function. Then the very next chapter is actually LCD, means limit, continuity, differentiability. Basically, in your in CBSE, limit has been covered in class 11th, and continuity, differentiability of the very next chapter or fifth chapter of your book. And after that, this is AOD. The next is application of derivative. Okay. So, and the very next is that indefinite integration. In short, I am writing indefinite integration. Okay. And post that, that is called definite integration. You will be friendly in few days, right? Now, if you listen that what is indefinite, definite, all those things, it's very complicated for you to understand. But going forward, like in 1 or 2 months, you will be like very friendly with these terms and these things, right? Definite integration. Okay. And the very next chapter is differential equation. In short, I am writing D. So definite integration along with AUC means area under the curve. So if you see these portions, why I noted all these chapters is basically these are the chapters coming under the unit calculus. Okay. So calculus. So basically the next few months will dealing with the entire unit of calculus. And in competitive exam, not only in terms of JEE, in any competitive exams you go, there is a very high weightage for this unit. And if your entire 12 syllabus, that's 70%, or you can say more than 60 to 70% of the syllabus is calculus. And in order to understand the calculus better, in order to understand calculus fluently, or say like to get a very good command over calculus, you need to understand function very well in depth. Function, the concept of functions, and the next is limit. Like it is very, very important. If you are very good at functions and if you are very good at limit, using limit or the concept of limit is very thorough for you, then it will be a very easier for you to understand the upcoming chapters, like what are very linked. If you have a very good command over functions and limit, then you can easily understand limit, continuity, and differentiability. And if you have a very good command over differentiability, then ultimately you can understand its application, that is application of derivative. If you have a very good command over derivative, then according to that, you will have a very good command over integrations as well, because it's the reverse process of differentiation, as you know. And if you have a very good command over indefinite integration, you will do very well in definite integration as well. It's just something similar kind of thing, but having some separate rules and other things. Okay. And if you are a very good command over definite integration, and indefinite expression, you can do very well in area under the curve as well as the definite integration. Okay. It is not very difficult. It's a very high weightage topic. So, but the concepts are very much linked. So if you have a very good command over these functions and limit in few days, like in upcoming classes, if you listen properly and do try some questions at your home, or practice a lot of questions of previous year, then definitely you will have a very good command, and definitely you will do very well in CBSE exams as well as in the upcoming competitive exams, or whatever the AITs are scheduled monthly once, you know. So you'll do very good in that exam as well. So let's start. So you understood in these previous 5 minutes we discuss what the importance of function. Now we'll jump into the topic right now, and we'll start from the basics only. Like very basic. I'll start from the zero level. I'll assume that you don't know anything. You have a very good idea about the function, relation only. Now I'll start with the function from the 0th level, and we'll go up to the JEE Mains level, and whatever the level required to solve the JEE problems or like CBSE problems. Understood? So see, so a few things will be boring for you, like you might have understood the definition of functions and everything in a better way from the 11th itself. They will feel your bored, but it will be a quick revision for you, right? So have patience, okay? So definitely in like today class or like tomorrow class in Sunday 10 to 1, there is math class, right? In that class, you will be able to reach the higher level that you need. Okay, so this in this class you might feel some kind of boring as you covered this topic already. Okay, so yeah, so what is mean by functions? What is your understanding of functions? Function is nothing but it can be considered as a relation between inputs and outputs. Okay, you can see the screen. Let's say input. Input means what? Let's say it's generally denoted by X, and outputs are generally denoted by Y. So your function is nothing but it is a relation between input. You are giving something as input to the functions, and that function has a property that it will give some output to you. Definitely, it is going to give some output to you, but with under one condition is that the property that is input is related to exactly one output. What does it mean? Means if you give certain X, take in a particular X, for a particular X, there will be a particular Y. No, simultaneously, you can't have like Y or Z at a time for a given single input, right? Let's say in my childhood days, or like 5, 7, 8, 10 years before, like if you have a 1 rupees coin, you can put in the coin box. Okay, in the box, there is a box for calling people. So if you put that 1 rupees coin in that box, and you can call for a single number for a 60 seconds. Okay. So if you put 1 rupees, that means one input, that is 1x, you put here, and you can only call to a particular number for a particular time. That is the output. That output means calling a number. The input is here 1 rupees coin, and the output means you can see that calling that particular number. So for a 1 rupees, you will only able to call a single person or a single number that you have dialed. So that is what the function is, something that giving a input and it is so putting in so it will take an input and it will give the output, and with the condition that all the inputs for a single input there will be a unique output. Okay, so we'll go to the mathematical definitions. I hope you have a very good understanding of the relation in past two classes, or in like you have a very good command over the 11th relation. So a function is nothing but it's the extension of relation. Okay, just like think about if I talk about a black horse. Okay, so what the difference between a horse and a black horse? Means it is again a horse, but its skin tone, or let's say skin color or the body color is black. So initially is a so it's a horse first, then it has some extra property that is the entire skin tone is black. That's why it's called a black horse. Okay, or a white horse, like that. The skin tone is different. So similarly, a relation, initially we know it's a relation is the subset of Cartesian product A cross B. But when it comes to the function is a special relation. We'll see that it's again a relation, but it has some special property like a black horse. It's a horse, but it has some extra property. So that we are going to see here, that let A be two non-empty set. Again, as you know that a relation is established between two non-empty sets. So here A and B are two non-empty set, and that is and a relation from A to B. F be a relation. Okay, and F be a relation from A to B. And you know relation means what? A subset of A cross B. It has been written in detail, a subset of A cross B. And we call it as a function from A to B. We call it as a function from A to B if satisfy these two basic conditions, these two conditions only, right? In the case of black horse, as I told, its skin tone must be black. Similarly, it's a relation. Again, it need to satisfy two simple conditions. The first one is for each A, there exists A belongs to B. Like if you take any element in the set A, the first set, there must be some element in B such that the order pair AB belongs to it. It's just simple. Like if you choose any element from the first state, then definitely there must be a B in small b in the capital B, that is in second set, such that the order pair A comma B belongs to the relation F. Okay, is that simple. And the second point is simple, as I told, like it's a relation between input and output. In this case, A is the input and B is the output. And as I told you, the output must be unique. The same point has been written in the second point, that is A comma B belongs to F and A comma C belongs to F. Matlab, that is what is happen. You can see that for A will get B. That means what? A is if you give A as input, then you are getting B. And the same time, if you give input A, then C, then definitely it won't be a function. Okay. But what we conclude that in that case, B must be C. B is equal to C. That means if you are saying something like A is related to B, then A is related to B, then B must be C in order to be a function. That means for every input, there must be an output in B as well as it should be unique. Okay. It's simple. So, so next point is if F is a function from A to B, A comma B belongs to F, as you know, and F of A is B. We read it as F of A is equal to B, where B is called the image of A under F, because F is something. So this is A actually, and under F, and it reached to B, right? So we called it as F of B as F of A. Means F took A to B, right? With the help of F, we reached from A as input and we got B as output. So we called B as image of A under F, and A is called the pre-image. Similarly, this is a synonym, vice versa things. If A is the image of B, so B is the image of A, then definitely A will be the pre-image of B. And sometimes we use the different word for the word functions in terms such as map, mapping, correspondence are used as a synonymous word for the word function. So we'll summarize it. So in simpler word, function satisfied basically two conditions. One is that a relation is said to be a function. Simply you can understand a relation from A to B is said to be a function if every element of state A should have image in set B, and that image must be unique. So again, the point, this is a uniqueness. Okay. So that each element of A should have the image in B, and every element in set A should have and only one image in set. I hope this is clear. This is understood to everyone. ठीक है, सबको समझ में आ रहा है? So I hope everyone is clear on this, the definition. So we'll see some example. If you see the example, that the relation between A and B, it's a Venn diagrammatically explain the relation like this. 1 is related to 4, 2 is 5, 3 is 5. So every element of A is related to some element of B. You can see that 2 is a different element related to 5, 3 is a different related to 5. Okay. And every element of A is related to some element. That's why it's a function. So it's not a function because why? You can see that this is 4. 4 is what the condition was, the initial condition was every element of A should be related to B. But here 4 is one element of A, this is not related to anyone. Okay. So that case it is not a function. We are not care about the B, the where B, the element of B are related or not, that doesn't matter. We should care about the A, that there must be some arrow from A to B for every element of A. Okay. So that's why it's not a function. Again, this is not a function. Again, 3, it's violating both the rules. You can see that for 3 there is no image in B, as well as if you see 2, you can see that 2 has 2 images. For 2 will get 6 and 2 will get 7, and 6 is not equal to 7, right? So that means it's again not a function. It's a function, right? The last one you can see here. 1 is related to 6, 2 is related to 6, 3 is related to 6. You can see that every element of A is participating in the relation. Sorry, every relation of A is involved in the relation 1, 2, 3. And every element of A has a unique image in B. Yes, for 1, the unique image is 6. For 2, unique image is 6. For 3, unique image is 6. Then it's a relation which satisfy both the condition of a function. So it's I hope this is clear to everyone. Through this example, we have a very good clarity on the definition of function. So it's a concept test for you. Can you guys reply me in the charts like which of the following is our functions? 1, 2, 3, 4. Just write 1 or 2 or 3 or 4. What is your answer? Quickly. First. Okay, very good. So you can see that the one is a function because 1 is related to P. Sorry, A is related to P. B is Q. C R D S. That means every element of A is related to B. That's why A is a function. But 2 is not a function because if you see the D part here, D does not have any image in B. So it's again following the first rule of to be a function. So gone. So it's not a function. So if you see 3 here, 3 has all the properties. You can see A is related to P, B is Q, C has image R, D has a different image as R. So it has all the things that is fine. But if you look at again 4, if you see A has multiple images, A has P and A has Q. So hence it's not a function. So which of the following is a function? 1 and okay. So 1 and 3 are the answers to this. Now, so again, one more test for you. Like check whether the following relation, the star is a relation from A to B, is a function. So A is set, A is here, B is here, and the relation is given to you. 3 is related to 8, 4 is related to 8, 5 is related to 10, 6 is related to 12. There are 4 images, 3, 4, 5, 6. You can see everyone having images or not. 3, 4, 5, 8 all are related and they are unique also. For this kind of question, you can directly draw the diagram. That will be better. Like you can draw this money diagram like this and 3, 4, 5, 6. Okay. In order to solve this kind of problem, always it's better to do 7, 8, 9, 10, 11, and 12. Okay. and then you can relate those things directly, like 3, 8, 3 is related to 8. Again, 4 is related to 8 as well. And 5 is related to 10. And 6 is related to 12. Done. Okay, you can see that this is, you can visualize now in a better way. The way it has been written, it is very, you can't visualize it, though you can see the relation completely and A and B, but this is a diagram representation help us to understand in a better way. So you can see that both the condition of function is fully satisfied, so it's a function. Okay. Yes, it is a function. Now, see the representation of function. So functions can be, you can see the function in a different form in different situations, or maybe as per our requirement we may write the function in a different form, right? The first one is that table form. Table form is simple, like the set of input in x, right? The set of input, as I told you, this is your input, right? Input, and this is what your output, right? This is input, this is output. So set of all the input are written in the first column, and set of output, that -1, 1, 0, 0. What it means? That -1 as a image 1, 0 image 0, 1 as 1, 2 as 1. And similarly, these things can be written in the order pair as well. So all are linked, right? It's a table, right? I just written in the table form, and this can be written in the order pair. So like in previous example we saw now, this is a function from A to B, yes or no? This is A, this is B, and this is a function from A to B. So similarly, so and this I can say that this is a function, right? Again, the mapping diagram. From here I can draw the graph as well. Sorry, the diagram, mapping diagram as well. So you can see that the table, this is the same function. That one representing by order pair, that is the same function, we write in a different form. Now from here you can draw this like. Now, if you see that algebraic equation also, we can write a function in terms of algebraic equation also. Like we just want to figure it out how they are linked to each other, y and x, right? If I see every time I can see that here, a -1, 1, it's a -1 square is 1, 0 square is 0, 1 square is 1, 2 square 4. So I got the pattern that every time you put x as input, then the output will be square of it. So then I got a mathematically relation between x and y, that y is equal to f of x is equal to x square. That means x is the image of y. Okay. So y is the image of x, and how they are linked, the relation between y and x from the beginning of this sessions, I told you, like it's a relation between independent and dependent variable, or you can say it's a relation between input and output. The relation is here, we saw the pattern and we conclude that this y is equal to x. And the same thing can be written in the graph also. Like this is the equation. If you have equation for every equation, we can draw the graph as well. Okay. So graph is from the 11th also you can see the graph of x square, like this is 0, 0. Put x at, this is your x-axis, right? X-axis means this is your input axis. Always remember, this is your input axis, and this is your y means output axis. Okay. So whatever the value of x, the input value will be always like this: 0, 0 times the output is 0. That's why it is 0. Okay. So the input again, the input is what? 1. If you give input means 1 x. Okay. X-axis, the output is 1. So that's why the point is this. So again, this is 2, and then it will be 4. Okay. So similarly, -1, it will be get again 1, and if any other values will like this. So if you put any other values as well, any other values like 1.2, 1.3, or 1/2, 1/3, all those values you also going to get an image. So the graph will be continuous, look like this. Okay. The graph will be continuously look like this. So what are the representation of function there? You can, depending upon the situations, you can use various way of representing function in a tabular form, in an order pair form, in a mapping form, or in an equation form, or in a graphical form as well. So any form, you should be very much comfortable to identify that it is a function. Okay. So see, So in a function, as I told you, we write y is equal to f of x. From there you can, so as I told you from the beginning that it is a relation between input and output. X is the input and y is the output. So this is the function. So generally we write in general way that for any x, y is the image of x, so y is equal to f of x. That means x has been transformed to y to f. So with the input is always called independent variable, please do remember, and y is called dependent variable, and this f is function. Okay, whenever I see, if I write it as like this, g of t is equal to s. That means what? G is the function, t is the independent variable, and s is the dependent variable. Okay, s is dependent variable, t is independent variable, g is the function. That means g is something that who's to t to s. Okay, to g. You got it. I hope this is clear to you. So now, so input means basically we called it as domain. Output means we called it as a range. Whatever the output we got, that is called range. And this basically name of the function. If you see that f of x is equal to 3x plus 1 is written, that means this is name of the function. F is the name of the function and x is your input. Okay, x is your input and this is your output. Okay, if I give x is equal to 0, so you will get the output as 3 into 0 plus 1, that is 1. If I give the output as 2, sorry, input as 2, then I will get x as 2, that is f of 2 we call 6 plus 1, that is 7. So I hope this is very much clear to you, like how we can represent a function. What do you mean by independent variable? I can choose the value of x independently, that is called independent variable. But according to that, the value of y will depend, because the value of y completely depend upon the value of x. Previously, we put x value as 0, we got output 1. So if I change the value of x as 2, then we'll get 7. So it completely depend on the value of x only. So that's why it's all of you got to understood. You understood that key value of x, value of y is depend on x. Okay. Next, basically you will get it's a very simpler thing. The function is defined f of x is 2x minus 5, right? Then the value of f of 0, f of 7, and f of minus 3, f of 0 will be minus 5. If you put x is equal to 0, and similarly if you put a 7, that means 14 minus 5, that is 9, and if you put minus 3, that will be minus 11. Okay. So this is the summary of the representation for a given function y is equal to f of x. X is input and y is output. Okay. And for x comma y belongs to a function, x comma y order pair belongs to a function. Y is equal to f of x. We write here x is independent and y is dependent. Okay. So the third one you will see most in the standard book, or most of the questions will represent this. This function is written as, in general written as f from a to b. That means we'll get to know that the name of the function, this is the name of the function, this is the input set, this is the possible output set defined by y is equal to f of x. That means the function name will be there, the set of inputs will be there, set of possible output will be there, and along with that, how the input variable and output variable are linked to each other. That in case it will be like x square, or in certain case it will be 3x plus 1, or in certain case it will be sin x, it will be sometimes it will be like log x. Okay. So depending on the situation, it will be different. So this relation will be keep changing. The relation between x and y, it will be keep changing, but the generally will write like this. Okay. Generally will write like this. So here A is the set of input that function can take, and B is the set of all the possible outputs. I hope this is very much clear to everyone. So if a function is defined by this. So how to find this is this kind of function will be very much friendly in the concept of limit and continuity and differentiability. This will be dealing with this kind of function. Initially, you will see the function is very straightforward. But this is a different type of function. What it says that the function can take any input as a real. This R is stand for real number. So function can take any real number. So any real number can be three things, right? either it should be positive or negative or zero. Yes or no? दुनिया का कोई भी real number, if you take any real number, you get the three things: either it will be a positive real or a negative real or a zero. So the functions will behave differently. For negative number, the output is 3x minus 2. You understood, right? X less than 0 means for negative input, the output of the function is 3x minus 2. And if you put 0, you will end up with 1. And if you put any positive number, you will be end up with 4x plus 1. Okay? So, so for positive number, it will be 4x plus 1. Okay? So now, so according to that, we have to find that f of 1. F of 1 is, so input is positive, right? So we have to put the value of 1 where? Here, 4x plus 1. So that will be 5. Similarly, f of minus 1. F of minus 1 is negative. Then input is negative. That means you have to put it here. Minus 3, minus 2, minus 5. Okay. F of 0 is exactly 1. If it is 0, then will we get 1. F of 2. F of 2 is what? F of 2 means the value is positive here. That will be 9. I hope these things is very much clear. So what we have covered so far, that is definition of function and representation of function. Next we will see two major things, that is vertical line test for identifying function. What is vertical line test for identifying function? That I will tell you that how it is important and how it helps to get the function, and domain, codomain, and range of function. So the okay. So the concept to be covered is vertical line test for identify functions. So far we have seen what is the definition of functions, how we'll represent the function. Next we'll see the vertical line test and domain, codomain, range of the function in detail. So see, what is vertical line test? Sometimes the function we saw that we can represent a function graphically as well, right? And sometimes if you have a only graph given and the question is to identify whether it is a function or not, then in that case what we will do? How will identify that it is a function or not, right? It's the only graph is given to you. So in that case, how you'll identify it? So you have to draw any vertical line that intersect the graph more than once. So you have to do some vertical lines. Okay. If that lines intersect the graph more than once, then the graph does not define a function. You got it right? This is the simple thing. How will remain vertical line test say that suppose a graph is given to you, we'll show some examples. Graph is given to you and the question was to identify whether it is a function or not. What you will do is that you will draw a vertical line. That means, as I told you, the vertical lines means y-axis is your output axis and whereas x-axis input axis. So you will draw a vertical line parallel to output axis, yeah, perpendicular to input axis. And if it got more than one point to that graph, then this is not. We'll see here. Okay. See, this is a function. How if let's say this function starts from this to this, okay, we start from A to B, end with A. Let's say this is A point and this is B point. You can see that this is the blue wala part is the graph, and you can notice that if you draw any vertical line, if you draw any multiple vertical line, that is also fine. Result will be same, right? Yes or no? You get the same result for any vertical line you can draw. You end up with see that they intersect at only one point. Okay. But here you can see that if you draw any other line apart from this, also you'll get a two intersecting point, this and this. Yes or no? This and this one as well. So that how what is happening basically, this you see for a particular x here, this is your input x, right? As I told you, always do remember that this is your input axis. and this is your output axis. That means for a particular input, we are getting two different output, right? Let's say this is y1 and this is y2. For a particular input x here, we are getting two different output. That's why the graph look like this. Na? When we draw x square graph, you can see that for a 1 will get 1. So this point we get. For 2, we get 4. So that's why this only 1 point we got. If it 2, we get different values. Okay. 4 and minus 4, then we have to put these two values, right? For 2, this is 4, and for 2, this is minus 4. If something happened like that. Okay. So that means you can see from here. So then it won't be a function. Similarly, for in the case of circle or ellipse, both the case, okay, it is not a function. If you draw a vertical line, you will end up with multiple intersection points, then it won't be a function. So next is what this vertical line test again. You can see that which of the following is a function or not. If you can see any vertical line you draw, it's going to cut only once or what you can see. So if you draw any vertical line, you can see it will cut the x-axis. Sorry, cut the graph of the given function at once only. Okay, yes or no? So that means all are functions. So here our conclusion is all are functions. All the graphs, they represents function. Okay, got it? Sure. Yeah. So now coming to vertical line, I hope vertical line test is very much clear to you. Like if a graph is given to you, how to identify whether it is representing a function or not. In that case, you just have to draw the vertical line parallel to the output axis. Okay, or y-axis you can call. In general, we write normally we represent x as input and y as output. So in that case, if it intersects more than one point, then you can say that it's not a function. If it is always unique intersection, then we'll call it as a function. Okay. Now next we'll come to the domain, codomain, and range. So in a simpler language, in a very simple language, okay, in a very simple, this is actually generally works for every function. So like as I told you, treat function as a something machine type of thing. What can go into the machine? So it's a mixer machine. Okay, if it is a mixture machine, you can't put something like a iron box into it. So it will break down its threads and everything. Like if it is a like wheat crusher machine, okay. And if you put or a rice crusher machine, if you put something like stones into it, it will break down with blade. So domain is something that if a function, what can go into it. Okay. What are the inputs you can give it to it? What can go into it? It's called the domain. And what are the possible outcomes? What may possibly come out of the function is called the code. Let's say in a let's say chemical laboratory, you have some like some ingredients, or let's say some salt or something you have, and you are putting in a test tube, right? You know what are the possible outcome can be. It can, the output can be a acid, or maybe a base, or a salt, or like anything. You know what are the possible things, you know, right? If I mixed all those things in a test tube, then the output can be out of this following something might happen. Okay, not exactly sure, but it might be these possible things can happen. So in that case, the possible, all the possible collection of all the possibilities is called the coder. Okay, if you're giving to input, you know these are the possible outcomes can come, and all collection of all the possible outcomes in the codomain. But what is mean by range? Range is something that what exactly came. So at the, let's say experiment happened and you saw that end, we got something like acid. Okay. So our conclusion that acid is exactly the range. Okay. So so we'll see in a better way that domain is the set of The set A is called a domain of the function, because A, for every A there must be an image in B. So function can take the entire set A. So the for a function, the first set, that function represented by F from A to B, so A is called the domain, and B is called the codomain. The set B is called the codomain of the function. So if your function is written in front of you, and if someone asks you what is a domain and codomain, it actually basically it's written in the question itself. That is A and B. A is the domain and B is codomain. What is range? Range is the set of all the map element, images, set of all y values in B. So whatever you've got, like if you give some input and at the end whatever you are getting, and all those collections, right? This is called the range. And you can see that codomain is a bigger set. Codomain contain all the possible values. Okay, all the possible values that function can give, all the possible outcomes. But range is that range contain exact item. So exactly, sometimes what the exact value may be equal to the possible value. In that case, range and codomain both the set will be equal. But majority of the case that doesn't happen. So range may be smaller set comparing to the codomain set. Codomain is a bigger set. So we can write range of F is subset, okay, or maybe equal, okay, proper subset or maybe equal to the codomain. Okay. Later we will see that if range is equal to codomain, then is a onto function. This function is called onto function. And if range is not equal to codomain, if it is a proper subset of codomain, that is called into function. Okay. So that's play a very important role, this into and onto function in the inverse function wala part, where the function is invertible. Okay, we'll see a lot of things on that as well in the upcoming classes. But for the time being, just to remember that the range is a smaller set comparing to the codomain set. Codomain is a bigger set. Okay. Now see the example here. If this is a function, let's say x is the input and y is your output. This is your y. Okay. If giving x and y as your output, that y is equal to basically 2x plus 1, 2 times of x plus 1. So if the input set is, the domain is 1, 2, 3, 4. From the graph itself, you can see 1, 2, 3, 4. What the possible values of range codomain is 1, 2, 3, 4. So that 1 to 10. They given 1 to 10 as codomain. But if you see the range here, 3, 4, 5, 1, 1. If you put 1, 2 plus 1, that is 3. If you put 2, that will be get 5, 3 is 7, 4 is 9. So that means the range is 3, 5, 7, 9, and the codomain is this. Domain is this. You can clearly see that a range is a subset of codomain. 3, 5, 7, 9 already inside this set. So range here, range is properly subset of codomain. Okay. Properly subset of codomain. So now we'll find the range, domain, and codomain of the function. This is the domain. This is the function is A to B. This is the codomain. The function is defined by y is equal to x squared. Okay. So clearly from this I can say that you can write the function f directly in this order pair form. One image is what? One image will be 1. 2 image will be 4, and 3 image will be 9. Okay. So from here, what you can say that domain is what? Domain is set A. Yes or no? The A is the domain. The entire set. I'm not writing it. B is equal to codomain. Codomain. And the range set will be, this should be 1, 4, 9. Yes or no? 1, 4. I hope this is clear. Domain, range, and code. Here. So now, depending upon the range and domain, the functions basically in up to the 12th we primarily deal with real valued function or real function mostly. But in like in the higher classes, like in engineering or in like master degrees, you'll deal with the complex valued function as well, or complex functions as well. Okay, but here we have a restriction. We have a limitation up to real valued function or real function. So what do you mean by real valued function? If A and B is said to be real valued function, if this range is subset of R, domain have no restriction, but the output, what are the exact output is coming, that is range. And if that is a subset of R, you know, various subset of R, it may be any interval, it can be real, sorry, it can be a natural number, it can be integer, it can be rational, it can be irrational, or it is a mixture of both. Okay. So in that case, if the range is a subset of R, then its value, the function value, the output is real. That's why it's called real value function. But what do you mean by real function? Real function is something with both domain and range is a subset of R. To be real function, if both domain and range is subset of R. Okay. Both domain. Here in the real valued function, there is no restriction on the domain. But if you call a real function, the real function means what? The function's domain and range both are subset of the input is a subset of R, and the output or the possible outputs or the exact output, the set of all the outputs is also a subset of. In that case, it's called a real function. So I hope this is clear to you. Okay. Next is the set of. So we'll input and notes on that. In a simpler way, the set of x values for which y is equal to f of x is defined has a finite value, define and has a finite value. So that means what do you mean by domain? If someone asks, you will tell him that I'll put x in that function, and if that function is defined and as a finite value, and as a output it is giving a finite value, is called a domain. Just like this, f of x is equal to 1 by x. If you put 0, 1 by 0, you know, non-zero upon 0, non-zero divided by 0 is not defined, right? Is not defined. So that means, so 0, 1 by x for the function f of x is 1 by x. X is equal to 0. The function is not a part of domain. Yes or no? Because it is not defined. So what are the things that need to be in the domain? Okay. So that we know it should be defined and a finite value. So any other values except 0, if you put that, like 1, 2, 3, 1.1, -2, -5, √3, √2, anything, you'll get a finite value. So the domain of this function is, you can see that this one, for any negative number, the √x is defined. I can say that -2 under root is not defined, -3 under root is not defined. Any negative number is not defined, right? But minimum value should be 0. From 0 it is defined, and any positive input you can give, so it is defined. So, and if you put any positive value, we can use any calculator. Let's say any bigger number also is fine, or any smaller number using calculator we can, or supercomputer we can calculate the under root of it. Okay. So the domain is 0 to infinity. Okay. And sometimes if domain is not mentioned, the domain is assumed to be the largest real value of x for which the function is defined. Let's say if a function f of x is equal to x square written, you can see that square of any number is defined, right? For any real number, the square can easily be found, right? You can take any positive, negative, 0, whatever the number, it can be defined. So anyone can take natural number as well, integer as well, rational as well. Yes or no? But the largest one for it defined, or someone can say that 0 to 1, or let's say any 0 to infinity, that can be also domain for this function. Okay, all this can be domain. Okay, this can be a domain, z can be a domain, q can be domain, 0 to 1 can be domain for this function, but the largest state is R. So that's why if this function is given and someone asks you what is the domain, you will tell the largest state, that is R. R is the domain. We'll always consider the largest value of x for which the function is given. Again, the same thing worked for the codomain as well. If codomain is not given, then assume to be real. अगर codomain कुछ नहीं दिया गया है, nothing is given, then in that case you'll consider. I hope this thing is clear on the domain and codomain thing. Codomain is as a domain is something like a very all the possible input that a function takes, and always will domain is nothing mentioned to us. In that case, we'll consider the largest real value of x for which the function is defined and finite. Again, similarly, the codomain case also is true. If nothing is given, then we have to assume that it's here. And now it's come to the image wala part. Sorry, range wala part. Collection of all the images is called the range of the function. It's primarily all the values of y for x is defined. आपने क्या किया previously? What you did is you put some x as input in the function, and in the you got according to that you will get some y's. So collection of all the possible values of y will give you the range. In other way, the set of all y values we get from the function y is equal to f of x by substituting all the x values from domain in the function is called as range. So आपने x put करते हो, whatever the possible y you got, and it's the collection of for a set of all values of y. Let's say the function is y f of x is equal to 2. If you fix the domain as 1, 2, 3, 4, what you will get? You get all the even number, because if we are multiplying by 2, one image will be 2, 2 will be 4, 3 will be 6, 4 will be 8. So like that, so 2, 4, 6, 8. This one, okay, done. So this will be our range, this will be a domain, and this is our function. No. So what we covered is that vertical line test, domain, range, and codomain. So initially, so far what we did, we covered the basics today. That is, one is what? One is primarily the representation of function, basics of function, what is function definition, then representation, then you come to the vertical line test for identifying function, and domain, range, codomain of a function. Okay. So next we'll see some standard function basically, because this will be very much helpful to you to understand calculus. Okay. Or many chapters you are going to draw those functions infrequently. What we will basically see in this function, standard function, we'll see the function range, okay, domain, and graph, and sometimes its property. Okay. The upcoming class, tomorrow class, we'll see these things for each function, for each function listed here. Identify function, identity function, constant function, polynomial function, rational, exponential, logarithmic, modular, binom, greatest integer, fractional part. For all these functions, we are going to see quickly the range, domain, graphs, and some properties of it. So one by one, we're going to cover tomorrow. So on detail on this, okay. And after that, we'll move to the 12th portion, that the type of function, that is on one, on two, into, bijective function, then the inverse of function. Okay. Before that, we have whatever the possible things we need to cover or need to generate the background we are doing right now. We're covering from the 0th level. We believe that you know nothing. Okay. And we started from the zeros, that from the 11th class functions only. And now we are here. So we have 5 minutes more. Let's finish the two basic functions, that is identity functions and constant functions. Okay. You can see that the function f from R to R defined by f of x is equal to x is the identity function. Identity means what? Whatever the input you give, and you'll get the output as the same as well. Let's say if you give input as 1, output will be 1. X output is x. 2, 2. It's just like a mirror. Whatever 3, 3, 4, 4. 4 images 4. So it will be something like that. Y is equal to x. This is f. How will write y is equal to f of x is equal to x. I told you how we represent the function. Like this only. Okay. So y is equal to x line. Y is equal to x line will be bisecting the third quadrant and the first quadrant. ऐसे जाता है 0 के टाइम 0, 1 के टाइम 1, 2 के टाइम 2, 2, 3 के टाइम 3. 4 के time 4 like this. So -1 -1 -2 -2 like this. So this will be going to this direction and extended to this direction. So this will y is equal to x. Okay, this will be y is equal to x. Okay. So you can draw the graph of identity function or the y is equal to x line. It's a straight line passing through, bisecting the first and third point. It will be ये याद रह जाएगा. So the domain is R. You can take any possible values of x. Possible values of x you can take. So you can see that it can take any values of x. And range is R. How you can define the range of R? You just see the height of the graph. Okay. It can goes up to infinity. It can goes up to infinity. It can extend. Like say for 1,000 it will be 1,000. For 1 crore it will be 1 crore. Yes or no? For 10 to the power 50 it will be 10 to the power 50. So it will be a very large number as you keep increasing the positive values. Similarly, if you keep decreasing, keep declining the numbers, like any giving any negative number as input, then in that case also you are going to get some very negative number, that is minus infinity. So its range is infinity. Sorry, its range is minus infinity to infinity ultimately. The next, so we're closing today's class from here. That is, next function is constant function. Constant function is something like whatever the input you give, the C will be the output will be C. Whatever the input you have, okay, whatever the input you have, the output is always going to be C. Okay. So that is called constant function. If C is positive, then the graph will be like this. It will be above the x-axis. If it is negative, it will be below x-axis, and if it is 0, it is x-axis. Okay. For C is equal to 0, this is actually y is equal to 0. Y is equal to 0 line is x-axis. Let's say if I am drawing y is equal to 5, then it will be something like this only. Y is equal to, if I said that y is equal to 4, so make it as y is equal to 4, then this will be the line. Yes or no? This will be the line parallel to x-axis. If I say y is equal to -4, it will be something like this. So y is equal to -4. So please do remember, the constant function has a range only C, because for every input the output is always going to be C. So that's why the range is C. Output क्या आता है? C ही आता है. Domain, it can take any real number. The domain is that how the graph will look like. Graph will always going to be parallel to x-axis, but if it will be above x-axis, if it is positive, C is positive. Okay. For C positive, the graph will above x-axis. For C negative, it will be below. So this is all about for today class. Okay. We'll meet you tomorrow at 10 a.m. We'll discuss further on this, like different type of function, its range, domain, and and graph. Thank you for your time. Thank you for joining and staying till the end. So I hope tomorrow will be a very informative. This session is this was a very much informative session for you, I hope, and tomorrow sessions will be much more interesting for you. Okay. So thank you. Bye bye. Take care.